All right, this is Algebra 1B, Part 1. This is Sample Work 1. So as you've been going through the unit, you've seen keywords. Write each keyword, write the definition, and provide an example. I'll do that here. We have, I believe, 12 words. Yep, 12 words for this particular unit. I'll go through them in the order in which they appear in the lessons. All right, so here we go. First word, gradebook weights. Gradebook weights. The gradebook weights are the percentage, a type of assignment, is worth. For example, let's look at your gradebook weights for Algebra 1B Part 1. I'm going to the Weebly website. Okay. And tests are 45% of the total grade. So tests are 45%, or nearly half of your grade are made up of tests. Okay. Gradebook weights. Question, or word number 2, portfolio. Portfolio. A longer assignment. Submitted in a Dropbox. Okay, an example, if I go to the Weebly website, go to Algebra 1B Part 1, there is a Portfolios tab. Okay, it looks like Unit 2 Exponential Functions portfolio is our example. Unit 2 Exponential Functions. Okay, and just to, this portfolio assignment explores the concept of exponents and applies them to growth and decay situations. Exponents represent repeated multiplication. The curriculum has you doing 3 tasks. I'm actually going to have you do the first 2. So this is a good reminder to always check my Weebly site. The 2 videos below explain and demonstrate step by step what I'd like you to do. Remember, this is not a case of just watching the video and taking notes. Use your own numbers and examples and calculate your own unique results. Do your work on paper, photograph your work, and submit the picture in the Dropbox. Okay, so that's an example of a portfolio assignment. Reflection. Reflection. This is a type of assignment that you have. Okay, it's usually before a test. And it asks you to think about how prepared you are. Okay. And for an example, I'm going to go to your grade book. Okay, I'm going to pause here while I find it. All right, so here's your Algebra 1B Part 1 course, and there's the course tree. And we're looking for a reflection assignment here. Here we go. The first reflection occurs right here in the mid-unit review. Reflection assignment. Okay, it looks like this here. Here we go. Start assessment. How comfortable are you with converting numbers between standard and scientific? How would you describe your ability to apply rules? Which of the skills do you think you can teach someone else? Which skills do you need help with? So it's a reflection on how comfortable you are. Unit 2, Lesson 5 is our example. So Unit 2, Lesson 5 has a review assignment. Okay. A reflection assignment. Resource. Resource. A video, a document, and other materials useful in the course. Okay, example. I'll go to my Weebly site here again. Okay, courses. Okay, go to my Weebly website, go to Algebra 1B Part 1, and there's a Resources tab. Okay, and there are videos here, like Unit 1, Lesson 2. In this lesson, I work examples of integer addition and distributive property. Okay, so the Resources tab is an example on Weebly. Okay. Next word. Next word. Distributive property. Distributive property. Okay, this actually is a property that is a formula. A times B plus C equals AB plus AC. That is, we can distribute the A to the B and the C, or we can pull the A out of the A, B, and the AC. It goes both ways. Okay, get an example. 2 times 3 plus 4 equals 2 times 3 plus 2 times 4. Just to verify, 3 plus 4 is 7. 2 times 7 is 14. 2 times 3 is 6. 2 times 4 is 8. 8 plus 6 is 14. Distributive property. Property and example. Integers. Integers. Positive and negative whole numbers. Examples: -3, -2, -1, 0, 1, 2, and 3, and so on. Positive and negative whole numbers, integers. Order of operations. Okay, the accepted order in which to do them. PEMDAS. Please excuse my dear, and I'm going to put MD in parentheses, Aunt Sally. PEMDAS. Please excuse my dear Aunt Sally. All right, an example. 4 minus 5, actually 6 squared, divide 4 times 3 plus 1. Okay, we do parentheses first. 3 plus 1 is 4. Times 4, bring down the rest of the problem. We do exponents next. 6 squared is 36. Then we multiply and divide from left to right. Always left to right if you have more than one of the same. So the divide comes first. 36 divided by 4 is 9. Then we do the multiply. 9 times 4 is 36. And then finally we subtract. 4 minus 36 is 32. Okay, and that's an example of PEMDAS. Notice the upside down triangle going on there. If you do it right, it should come out kind of like that. Order of operations. Okay, time to make a little room here. Linear equations. Linear equations. Equations whose graphs are straight lines. Example, y equals 2/3 x plus 1. Starts at 1, goes up 2 and over 3, up 2 and over 3, over and over. Its graph is a straight line. Graphing is a straight line, makes it a linear equation. Variables. Letters representing unknown or changing amounts. Okay? The formula A equals pi r squared. These are variables. A and R are variables because they represent quantities that change or are unknown. Linear function. A formula taking input and giving output whose graph is a straight line. Okay, it's like a linear equation, really. So let's say instead of y equals, we'll say f of x equals 2/3 x plus 1. F of x behaves like y, where x is the input and f of x is the output. Slope-intercept form. For a linear equation, that is y equals mx plus b. Example, y equals 2/3 x plus 1. Okay, b is known as the y-intercept. M is known as the slope. When we graph, we start with the 1, and then we go up 2 and right 3. Okay, system of equations. Let me make some room here. We're down to the last one. System of equations. Okay, more than one equation. Here's an example. I'm going to use the rest of the space. Y equals 2/3 x plus 1 and y equals 2x minus 3. Okay? Here's how I'm going to solve it. I'm going to solve by substitution. Y is the same as 2x minus 3. Here's a y. Replace it with 2x minus 3. We end up with 2/3 x plus 1. I'm going to get rid of the fraction by multiplying everything by the denominator 3, right here. So multiply by 3 by distributing. So we get 3 times 2 is 6x, 3 times 3 is 9, 3 times 2/3 is 2, just cancels the 3's, 3 times 1 is 3. I'm going to subtract 2x from both sides. We get 4x minus 9 equals 3. Add 9 to both sides. We get 4x equals 12. Oh, that's going to come out even. Lucky. Divide both sides by 4. And x equals 3. Now that x equals 3, x can be replaced with 3, and here's an x on the other side. Replace it with 3. Y equals 2 times 3 minus 3. Y equals 6 minus 3. Y equals 3. Okay, and we can verify in Desmos. Okay, let me bring up Desmos. And we can graph the two equations and see where they cross. Y equals 2/3 x plus 1. Y equals 2x minus 3. And look where they cross at 3, 3. So it works. System of equations, more than one equation. We solve by graphing and by elimination, or substitution, not elimination. All right. Make sure to put this in the Dropbox, or if you're redoing it, send it by webmail.